Were you one of the millions of Americans who saw the recent eclipse? Did you know that something is wrong between what you were witnessing and what the scientific community told you what you were seeing? It's called cognitive dissonance, and we've all been told a lie. A couple of days before the Great American Solar Eclipse, I watched a YouTube video where the questions of the size of the moon's shadow was raised. If you haven't been paying attention, then you wouldn't know that people are questioning how catastrophically tiny the shadow is in relation to the actual size of the moon. Not only is the diameter of the shadow a physical impossibility, but there is another physics problem regarding the eclipse that has been totally overlooked, and once again concerns a critical error in planetary physics. Have a look at this photo. I took this photo myself and zoomed the camera slightly so the moon would look accurate in the photo to the size I was observing with my own eyes. I think I did a pretty good job at getting the dimensions right. Now, the moon is 27% of the size of Earth, so if I was to take this picture and adjust the moon to fit, then pretend that I took this photo from the moon, then this is how big the Earth would look relative to standing on the moon. It's pretty big, isn't it? Given the sheer size of Earth in the sky, one would correctly assume that light reflected towards the moon would be greater, but it gets better. Earth is actually more reflective than the moon, and this is the problem. When NASA sent the astronauts to the moon, they forgot to send a light meter that could deliver accurate readings back to Earth of Earth light during the lunar night. This would have given scientists a dead accurate account of the Earthshine on the new moon, but because no permanent instrument was ever sent to the moon, ever, astrophysicists still have to rely on mathematical equations to model how much reflected light to expect. Sana Dolichva, an astrophysicist from Melbourne, Australia, wrote this on the subject. The moon has an albedo, which is the measurement of how much light is reflected without being absorbed, of 0.136. The energy the full moon is reflecting at the Earth is 0.0037 watts per meter squared. For the purposes of comparison, a 100 watt light bulb from 10 meters away has a brightness of 0.02 watts per meter squared. Remember, the moon is actually dimmer than that. Now, we've all experienced moonlight and shadows during a full moon, so we all know how bright the moonlight is. The Earth, on the other hand, has an albedo of 0.306. The energy Earth reflects at the moon is 0.12 watts per meter squared, so because it's bigger and more reflective, the Earth, as seen from the moon, gives off about 32 times more energy per second. That means the full Earth in the lunar sky is roughly 32 times brighter than the full moon in the Earth's sky, and 6 times brighter than a 100 watt light bulb. Now, given that amount of light, and given that the Earth lost only a tiny fraction of light from a piddly 70-mile black disk during the eclipse, where then is the Earthshine upon the moon when it otherwise blocks out the sun? This is what one should expect from the scientific model as the moon blocks out the sun, and likewise, the sky should also be a pale blue 70 miles either side of you. So why does the moon not glow even a fraction in the bask of Earthshine during a total solar eclipse? It's physically impossible that the moon remain pitch black when 98.3% of the reflected light from a full Earth was directed squarely at it during the recent American eclipse. Our scientific community headed by NASA has never explained planetary mechanics correctly when discussing the moon shadow cast upon the Earth during a solar eclipse, and neither does it communicate on the complete lack of planet shine that the moon should be receiving from Earth. Given that neither physics models are demonstrated during a total solar eclipse, there are two propositions that the global community now need to ask. If planetary mechanics is not being demonstrated during an eclipse, then where are we? And second, why is the scientific community not being forthright with the same question?
Charlie!